Welcome to my mathematics session. I am continuing with the Fourier series, but this is a different problem. This is harmonic method of the harmonic analysis. Here, if you are given, you will not be given a function straight away to get the Fourier series of the function in a particular interval. Here what will be given is that you will be given the interval at the points. What are the values of the f of x? For example, you are given that this is a problem where your function is not directly given. You are given x and the corresponding y values are given. Now you are supposed to find the Fourier series for this up to two harmonics, in the sense that find the Fourier series up to two harmonics. That is find a0 by 2 plus a1 cos x b1 sin x plus a2 cos 2x plus b2 sin 2x. Now you see that these are the Fourier coefficients. I have taught a0, a1, a2, b1, b2 are Fourier coefficients. Now you see that we have to find the value of this. For this we actually prepare the table. See, what is the table that I have prepared here? X values, can you see the x values here? 1, 2, 3, 4, 5, 6. So it is actually, the next one is 2 pi. So 0 to 2 pi is the interval on which the curve stands. The corresponding ordinates are 1.9198, 1.30, 1.05, like that it goes on. These are the only x values and the corresponding ordinates are given. Now we use the trapezoidal rule of the area of a curve and the x-axis. That is, the meaning of this, a to b, I will take 0 to 2 pi itself, 0 to 2 pi f of x dx. See, this is nothing but the area of the function f of x in the interval 0 to 2 pi on which it stands. Now, trapezoidal's rule, what it tells you is that it is nothing but, the trapezoidal rules states that it is h by m. H by 2h. It is into y1 plus y2 plus dot 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 ym. This is your right. This is called your right hand value. See, you see that this is. See, actually I can derive this. What will happen here is that here, if you are going to do this, here half h, and you will get half, and you will take like this. Yes, this is correct. H by m. Now this is the formula, trapezoidal rule for finding the area between f of x and the x-axis between 0 to 2 pi. And this m is the number of divisions that we make on a to 0 to 2 pi. y1, y2, y3 and ym are nothing but ordinates. Actually, we use the concept that if you take yi, here you take this yi, you take this yi plus 1, the height is h, and what is the area of this? This is half h into yi plus 1. So this is the area of one bit of the trapezium. That is, the curve will be divided into lot of strips like this. y1, see, it is like this. Can you see this here? Here somewhere it will be, the next one will be like here like this, and it is like this, it is like this. So you see that here h is a constant, and you will have ordinates, and you find the area of each trapezoid and you sum them up, you get the what? The area of the trapezium. That is nothing but the area of this f of x, between f of x curve and the x-axis, and it is between 0 to 2 pi. So this is all the simplest idea that here you have. Now you see that this one, so we are going to use this particular idea to get solve this problem of finding the Fourier series, finding the Fourier series up to 2 harmonics. 2 harmonics in the sense that up to 2x. Suppose if they ask you to get the Fourier series up to 3 harmonics, means what? a3 cos 3x plus b3 sin 3x. We will stop there. So it will not be more than 3 harmonics. So let us try to find out. Now our job is to find what are the values of this a1, b1, a2, b2, and like that it goes on. We can find to any number of these Fourier coefficients. Now these are all Fourier coefficients. Now what we will do is, say I will just straight away give you the formula. One, I will do the rest of the things. Say what is that you want now? Here you want this a0. A0 is a Fourier coefficient. This a0 is nothing but what? A0, actually, how do you define this a0? A0 is nothing but 1 by pi 0 to 2 pi f of x dx. So you see that this is nothing but what? This is nothing but your h. See this 2 pi by m. Actually speaking, this is h is nothing but what? H is 2 pi by m. This is h is 2 pi by m. That is, you take this 2 pi and divide it into m equal parts. So the value of this h is nothing but 2 pi by m. See, can you understand what I mean here? So you see that this 2 pi by m means what? This 2 pi by m is nothing but, take this 2 pi by range and divide it into m equal parts. So at every point, for x1 you have got y1, for x2 you have got y2, x3, y3, like that it goes on, and therefore the area is given like this. So this is my right hand. Now you see that this a0 is equal to 1 by pi. This is the formula we know, a0. So here it is 1 by pi into, now you see that what is the value of this? What is the value of this? This is nothing but 2 pi by m into sigma of yi, I is equal to 1 to m. So you see that this and this goes off, 2 by m into sigma of yi. So this is your a0. So what is your a0 now? a0 is equal to 2 by m into sigma of yi. So this is an. Now what is your an? We know what is an. What is my an? What is my an? An. What is the coefficient here? It is 1 by pi. Then it is what? It is 1 by pi into, it is 0 to 2 pi into f of x cos nx dx. So this is my this one. Now you see that this is 0 to, now if you multiply this by cos nx, you have to multiply this also by cos nx. So you see that this is 0 to 2 pi into, what is that you will get? Here 2 pi by m, 2 pi by m into what is this? 0 to 2 pi, 0 to 2 pi f of x, see it is like this, 0 to 2 pi f of x multiply this by cos nx, dx will be equal to, it is 2 pi by m into sigma of yi into cos nx. So in this place 0 to 2 pi, here you have got here, this will be replaced by what? 2 pi by m into sigma of yi cos nx. So these two will go off, pi and pi will go off, giving you what? Pi 2 by m. So this is, so here you see that your 2 by m, so this will be equal to 2 by m sigma of yi into cos nx. So what is your an? It is equal to 2 by m into sigma of yi cos nx. And see here I will tell you what it is. See, now you multiply this 0 to 2 pi, multiply it by sin nx, dx will be equal to 2 by 2 pi by m into multiply this yi into sin nx. That is what I'll get. Now simply, now what is your bn now? We know that bn is 1 by pi 0 to 2 pi f of x sin nx dx. Now what is this? See, 0 to pi sin nx dx. Into so So this is what is. So you see that Bn is nothing but what? 2 by m sigma of yi sin nx. So these are the formulas that you must use to get these things up to. Say if you want this, that is first harmonic A1. First harmonic means A1. A0, first harmonic means A1, B1. Second harmonic means what? A2, B2. Third harmonic means what? A2, B3. See here we have got here. See here you must know that it is, if you are taking 1 means what? It is y1 cos x. It is yi cos x. B1 will be what? 2 by m sigma of y sin x. See here I will explain everything here. So from trapezoidal rule we are able to get the Fourier series constants like this. The Fourier coefficients can be got in this way. So these are the 3 formulae which you must remember if you are going to attempt a question on this. These are called harmonic. First harmonic, second harmonic, third harmonic, kind of like this. Now let us start doing this. Now what is that here we have done here? Here you see that I have prepared the table in which I am trying to find the values of this. That is, I want here, say I want cos x. See, I want a1 cos x. See here, a1 means what? What is your a1 here? a1 will be equal to 2 by m sigma of yi cos x. So you see that I have written here sigma of y cos. See here you have got y cos x. Here y1, y2, y3, y4, y5, y6 into cos x. Then if it is sin x, y1 sin x, y2 sin x, you know what is the meaning of this? It is y1 sin x, y2 sin x, y3 sin x, y4 sin x. The meaning of this is, see if it is like this, sigma of y cos x means, if you mean this, it is y1 plus y2 dot 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 y6 into cos x. So what is that? Here you have got here, see y1, y2, y3, y4, y5, y6 into cos x. Add them into cos x. So this is your first Fourier coefficient A1. So we prepare the table. How do you prepare the table? I will explain this. So you see that, let me come to this. So this is divided into 6 equal parts, 0 to 2 pi. 1, 2, 3, 4, 5. So this is pi by 3, then 2 pi by 3, then pi, 3 pi by 3, 4 pi by 3, then 5 pi by 3. So this is at this place you got, see, y1, y2, y3, 1, 2, 3, 4, 5. Here 0, see 0 we have got here. 0, y1, see 0, y1. Then pi by 3, y2, y3, y4, y5, y6. Then you see that 2 pi is there. So it is divided into 6 equals, see 1, 2, 3, 4, 5, 6. So here it ends here. So 0 to 2 pi. So you see that this is your interval and it is divided into 6 equal parts, and at every point you have got what? y1, y2, y3. We use the trapezoidal rule and thereby we are able to arrive at this. Let me take this point. See, let me come to this point. Y, pi by 3. Now what is pi by 3? Pi by 3, see pi by 3 is there. Its corresponding y value is 1.30. And you want cos x, sin x, cos 2x, sin 2x. So you see that cos x is, cos 60 degrees is 0.5. Cos 30 degrees is root 3 by 2, it is 0.866. Like that we find what is cos 2x. Cos 2x is cos 120 degrees. Cos 120 degrees is minus sin 30. So you get it as what? It is 0.05. Like that it goes on and you find. And after then what is that you want here? Y, see I have got here y cos x. See I have got here this formula y cos x. See y cos x, here y cos x. So for everything you find y cos x, then you want y sin x. Then y cos 2x and y sin 2x. See here I want, see what I want here, y, see this a1 is nothing but summation of y and cos x. What is this y a1? A1 is nothing but what? A1 is sigma of yi into cos x, something like this. So this is, so I am finding that, see I am finding that only. So here a1 is nothing but what? Y cos x, y1 cos x, y2 cos x, y3 cos x. So like that it goes on. So up to y5xx. And likewise this is also what? It is y1, it is y1 sin x, y2 sin x, y3 sin x, y4 sin x, y5 sin x, y6 sin x. Like that this is y sin to cos 2x, y1 cos 2x, y2 cos 2x, y3 cos 2x, y4 cos 2x. Like that it goes on. So that these are your Fourier coefficients which you can substitute here. Now you see that we find here, as I told you, if you take pi by 3, it is value is 1.3. You find what is the value of cos x, cos pi by 3, sin pi by 3, cos 2 pi by 3, sin 2 pi by 3. Then what is the value of y? Then y cos x you got here, y sin x you got here, y cos 2x you got here, y cos. So this is for pi by 3. Like that you take for what? At each and every point. This is 2 pi by 3. For 2 pi by 3 similarly you find. For pi you find similarly. For 4 pi by 3 you find similarly. And therefore this is nothing but your A1 Fourier coefficient. So sum it up and keep it with you. B1, this is your sum it up and keep it with you. And likewise you get like this and you this is the table. From the table it is now easy for you to calculate. So how do you calculate that? Now let me start writing that. What is your A0 now? A0 is equal to 2 by 6 because m is equal to 6. 2 by 6 sigma of yi. So what is your A0 here? See, sigma, this is your 4.5. This is 2 or negative. Add them, you will get 4.5. So it is 1 by 3 into 4.5, that is equal to 1.5. Then what is your AN now? AN is equal to 2 by 1 sigma of yi cos x, because it is cos x here. See this one, A1. This is what I will find. See A1, this is your this thing. 1.12, see it is 2 by 1 by 3. 1.12. This is the value. See this is, see this value is 1.12. So this is equal to, it is a 0.373. So this is one. Then this is your A1. It is A1 means A1. Then what is your B1 now? What is your B1? 2 by 6 into sigma OI sine x. So this is your B1. Add up 3.014. See, 3.1 by 3, 3.014. So 3.014 means what? This is 1.005. Then A2 is what? This one. So I have found this. I will find this. What is your A2? A2 is this. So what is your A2 now? 2 by 6 sigma of y cos 2x. So this is equal to, this is equal to 1 by 3 into, you see that this is 2.67. So this is equal to how much? 0.89. Then what is the A3? This is B3. 2 by 6 into sigma of y sine 2x 1 by 3. See, this is your, see, can you see this y sine 2x? This is your summation. y1 sine 2x, y1 sine 2x, y2 sine 2x, y3 sine 2x. Like that it goes on up to what? y4 sine 2x. Add up everything, minus 0.328. Minus 1.9. So this is, so I have got all the coefficients. So these are the coefficients. See, I will repeat this. A0, see, we have got the formula here. See, you have got this A0. A0 is 2 by m into sigma I, sigma yi. So this is sigma yi is 4. I am just showing by hand. This is your y, y1 plus y2, y3, y4, y5, y6. If you add them, you will get 4.5. Therefore, 2 by 6 into sigma of that, that is you get 1.5. Then you want what is your A1. A1 is nothing but what? 2 by 6. This is a formula. M is equal to 6. 2 by 6 sigma of y into cos x. Now, where do you get this here? It is y1 cos x, y2 cos x, y3 cos x, y4 cos x, y5 cos x, y6 cos x. You add them, it comes to 1.2. So it is 1.12 divided by 2. So this is your A1. That is the Fourier coefficient A1. Then your B1. What is your B1? 2 by 6. This is a formula. 2 by 6 into sigma of yi sine x, because put n is equal to sine x, because I want sine x here. Now, so what is that you get here? So come to this. This is y1 sine x, y2 sine x, y3 sine x, y4 sine x, y5 sine x, y6 sine x. So you get 3.014. Divided by 3, you will get. So this is your Fourier coefficient B1. Come to A2. That is 2 by 6 into yi. It is cos 2x. What is that? Because I want the second harmonic. It is cos 2x. So what is that you will get? Here you come to what is your cos 2x here. So it is y1 cos 2x, y2 cos 2x, y3 cos 2x, y4 cos 2x, y5 cos 2x, y6 cos 2x. Sum it up, you will get 2.67. Then you divide it by 3, you will get 0.89. Then what is your B3? B, it is B2. It is not B3. It is B2 because A to B2. Now what is a B2? B2 is 2 by 6 yi sine 2x because your second harmonic. So you come to this last column, y1 cos 2 sine 2x, y2 sine 2x, y3 sine 2x, y4 sine 2x, y5 sine 2x, y6 sine 2x. Add them, you'll get minus 0.328. I have put here and divided, so it is minus 0. So I am able to get all the Fourier coefficients required for this Fourier series. Are you able to understand? Now you substitute, you will get the answer. So what is your Fourier series now? Therefore, I'll write here, therefore Fourier series is A naught by 2, call this as your 1. Substitute these values in 1. So substitute these values in 1, you will get the what? Fourier series. The Fourier series is, what is your A naught? 1.5 by 2 plus A1 is what? 0.373, it is cos x. See? Cos x. Then what is your B1? Plus B1 is 1.005 sin x. Plus what is the A2? A2 I have found here 0.89 cos 2x minus B2 is this minus 0.19 sin 2x. So this is what you get. Therefore, Fourier series up to 2 harmonics is 0.75 plus 0.373 cos x plus 1.005 sin x plus 0.89 cos 2x minus 0.129 . This is the answer. So this is how you do find the harmonics, that is the harmonics of the Fourier series. So in general, I just sum it up. The problem is over. Remember that these are the formulas that you must remember. So this is very, very important. You keep this, and taking these values, you prepare the table like this, and then from, see, you sum up everything. Don't worry about this. You got y cos x column, y sin x column, then y cos 2x column, y sin 2x column. Keep that. Write the Fourier series up to 2 harmonics, and A0 you can get it from here, A1 you can get it from here, A2 you can get it from here, B1 you can get it from here, and B3 comes here. Using this formula, substitute them, you will get the answer. So this is all about your finding the Fourier series up to certain number of harmonics. If it is required to find up to 3 means, you will go create 2 more columns, that is sin 3x, cos 3x, sin 3x. Then you will find A3, A1, A2, A3, then B1, B2, B3. Substitute the values, you will get. So this is how we do the problem in what? Finding the Fourier series up to certain number of harmonics. I'll continue with, I will explain how to do problem, because this Fourier series will be applied in heat and wave equations. I will teach you a problem how to solve heat problem and wave equation problem in the coming days. Thank you.